Well, g'day, Max here again, welcome back to the shop. So our first project for 2020 is our R8 arbors. So we're going to make a selection of arbors for the Bridgeport. As all my current tooling, well the majority of it's all number 4 Morse taper. So we've got some decent quality scrap lying around, we can pick and choose to get something decent. We're going to do our best to try and keep it within the range of the hardness of the commercial stuff. So we'll run a hardness test file over some of these and see where we're at and compare that to our material we're going to use. So, okay, we're just using our hardness test files here. These are quite good. So I think the best quality one I think will be this one here, our ER40 pellet chuck. This is a Mechanica brand. It's a Taiwanese one. It's very good quality, no run out. So we'll just check in a couple of spots. So the 40 skates off it. As does the 45 skates off it. Actually that was a 50. Let's just redo that. Yeah. It's scratching it, it's not biting in. So we'll go to a 55. Starting to bite in. So this arbor's in between 50 and it's less than 55 anyway, but greater than 50. So we'll try another one. We'll start down the low range again. And that's skating off on the 40 Rockwell. So we go to a 45 and try a 45. That's just trying to bite in now. So this one's a bit softer than this one. So this is actually a Chinese one. So we'll go to another one here. This is a Chinese one. This is one I've adapted for the boring head. And that's trying to bite in too, and that's only 40 Rockwell. So if we can keep our arbors as close as we can to 50, I think we're going to be well in line with a lot of the commercial stuff that's out there. So I have selected a piece of scrap we can make it from. That's coming up, well, it's less than 55 and it's approximately about 50 Rockwell. So unfortunately it is a big long piece, so normally I would just get the 9-inch grinder with a cut-off disc and chop it to size, but because it's summertime here in Perth, using a 9-inch grinder in your backyard, cutting 2.5-inch diameter steel to 2-inch diameter steel, it's not really the recommended practice, as everything's tinder dry around here and things tend to catch fire. So we'll do it in the lathe. We're going to have to set up the steady rest in the lathe and remove the tailstock. So let's swing around, we'll get the steady rest set up. Okay, what we've done, we've measured the outside diameter of our material we're going to use, the big long bar, and we've got a piece of scrap in the lathe here, and we've machined the diameter of the scrap the same as the diameter of the bar. And what this will enable us to do is accurately adjust our steady rest. Get that mounted up. If your steady rest isn't centered, you know, when you have a big long piece in your chuck, apart from doing damage to your chuck, it will have the tendency to make the part walk out of the chuck, and and believe me, you do not want that to happen. Okay, so we just nip down our steady, and we just adjust up the fingers. Until they're making contact. Okay, so we'll nip those up. We're not too worried about the top one, as we'll adjust that one once we have the work in. So that's how you centre your steady rest. So we'll get that removed now and we'll get our bar chucked up. Okay, so we have our bar chucked up in the lathe, so we just need to true it up with an indicator, and we have the steady rest supporting it further down the back. And it does overhang the rear of the lathe a fair bit, so we'll get our indicator in, and we'll set up a parting tool and we'll see how it goes. Okay. Might move the camera back a bit so you get a bit better view of the entire process. Okay, we will be running the lathe at a slow speed due to the hardness of the material, and we'll be using lots of flood coolant as well. We'll see how it goes. Back that speed off just a tad. I'll have to change pulleys on the motor, so I'll just swap the belts around till we can get to the lower range of speeds. Okay, we've dropped it right down to 70 RPM. That's our slowest speeds on this lathe. So I'm hoping the core of the steel may be a little bit softer. flipped it up, back up to 110 RPM now. We're into the softer core. Just keeping an eye on where we're at with the parting tool, our diameter that we have inside. We don't want to part all the way through, we just want a little thin bit that will support the shaft so we can snap the shaft off. I'm just going to push the parting tool a little bit further out in the holder. So we've got a piece, we're about We're about 10 millimeters, 3/8 diameter piece still in there. So we'll just go a little bit more, then we'll be able to snap that off by hand. Okay, I think we'll let that go at that. There we have it. Okay, parting this length off here, I could not stop the bar from chattering. I tried, sometimes it'll work if you put a slightly blunter insert in when you're parting hard steel. That sometimes works. I tried that, that didn't work. So I'll flip the tool upside down, run the lathe in reverse, and it's cured the problem. So. Let's see if we can't speed it up a little bit. inspector, come to make sure we're chopping all our parts off to the correct length, eh? Okay, so we've got all our blanks cut off for our arbors. So what we have, this one here will be for the side and face mill cutter arbor. Then we got two here, it'll be for these face mills. One here for the ER40 collet chuck, and two here for slitting saw arbors. Now with the slitting saw arbors we're going to go a different design than what's normally out there. The bottom cap will be held in by the drawbar retainer, and it'll be a piston type. So we'll explain that one once we get a bit further into it. Now you can see I've faced and centered one end of all of the pieces, but you can see here the focus camera. Okay, don't. The depth of this hardness is down 3/8 of an inch thick. So we'll have a bit of tough turning to hog all that off. So anyway, the other one we've got to do is the arbor for the boring head. Now this boring head, I got this dirt cheap because Chinese thing, and they've misdrilled the PCD on these holes. So I've machined the other end of this MT4 arbor, and it relies on this ring holding it in. So what I'm going to do is make a solid one-piece one out of this pin here. So that should get us enough tooling to get going on the Bridgeport for our future projects. Okay, we'll make this one the first cab off the rank. So this will be the arbor for the boring head. So the tips we're going to use, these are Dorian tips for hard steel. That's the back of the packet. So we'll probably try 300 RPM with an 1/8 hour feed rate. We'll see how that goes. And we're only going to do moderate depths of cut because like this is like 50 to 55 Rockwell. This pin, it's an old Caterpillar pin. It's actually a bowl lift pin off a Caterpillar 657 scraper. So we'll give it a go and see how she goes. Feeling that now it's going to be pretty hard, so we'll go on 30 thou and see what happens. And what we'll do is we'll just drop that down. We'll drop our speed down a little bit on that one. Okay, we'll drop it down to 160 RPM. We'll see how we're going. The diameter of this is 80 mil, 3 inches. It's liking that a lot better. Slowed our speed rate down to 6 now and increase the depth of cut. Well, that seems to be getting through that okay. The tip's standing up okay. So we've got to come back 4 inches. Where are we? Hard to read this ruler in this light. So we've got to turn back 4 inches down to 1.250 diameter. And then the rest will step up here for the flange for the boring head, and then we'll part her off. Well, the cover that we made the other week seems to be performing flawlessly, keeping all of the rubbish out from going in behind the apron. Okay, we're still 250 thou up on size on this diameter here. So what we might do now, we might part it off now while we're still got a bit of thickness left here. If we go too thin, if we take this too close to size, it will affect how this thing handles when it parts off. So we just want to keep a bit of rigidity there still. So we'll see how she goes. I think we'll start off on a slow speed again. We'll try back down to 70 RPM, being as we're still in the 55 Rockwell area up here. We're down to 40 down here. So. What I am going to do is shorten this blade right up for the initial first part, because there'll be a lot of tool pressure initially. As I say, it takes an immense tool pressure to part this stuff off at this diameter. There we are, we're into it now. And some long, ugly, stringy chips come off this. There's nothing you can do about it. We'll just pull up here and get rid of this mess, I think. Okay. That's going through that nice and easy now, as we're through the worst of the case hardening. Put that tool out a bit more. Always important to keep this tool up very short, keep that chatter away. Yay! Okay, well, that's our piece successfully parted off. So all we'll do now is we'll chuck it up on this end here, and we'll complete our roughing out stages of this part here. This is where the R8 feature is going to be, and then we'll swing it around, and we'll face this to length, and there's a step feature we have to machine on this end, as well as a PCD for the mounting bolts. Then we'll flip it back around. We'll bring this down to probably 1/8 thou above our finished size for the grinding allowance. Plus we have the R8 features to machine in here too, so we'll leave all that 1/8 thou up on size. And we will be finishing this part between centres, so we can flip it. Once we've finished this part, we can flip it around and finish this face here, and it will still run true. Well, that's our first cab off the rank, so just a few things to finish roughing out on this one, and then we'll move on to the the other pieces and get them all roughed out as well. So it's a bit of tough stuff to get through, but it's not impossible, can be done as we've just done it here. So you just got to think about how you're going to approach it, keep your speeds down until you get under the hardening. That was the same tip. We didn't change the tip at all doing that piece there, and that's plenty of flood coolant, and keep your speeds down and your feeds up as far as you can. You know, we were working on about an average of an 1/8 hour per revolution feed doing that. So thanks for watching, and we'll see you in the next video. We should have the bulk of the roughing out done on these, and then we'll get into the finishing procedures. Catch you later.